Hello everyone, my name is Mike Lamb, and welcome to the first mini lecture for CS 261. This is an introduction to computer systems. And so before we do any sort of discussion of technical content, I actually have a couple of questions for you to consider. So here's the first question. What do you suppose is going to be the output of this C program? Now, I don't necessarily expect you to know C at this point in the semester. In fact, I expect that most of you do not know C. But you can sort of rely on your intuition from Java here. So this is a program that has two different variables, x and y. We set x to be 40,000 and x to be 40,000 and y to be 50,000. And we simply we square each number and we do a comparison. And if the square of x is less than the square of y, it'll print less than, otherwise it'll print not less than. So think for a second and think about whether this is going to print less than or not less than. Maybe pause the video. I may leave a link below the video for an online IDE where you can go and try this out. But so think for a second about what you think this program will do. So hopefully you can draw on your math knowledge to realize that what this program should do, or what we might expect it to do, is to print less than, because the square of a smaller number is always mathematically going to be less than the square of the larger number. But in fact, if we run this on a typical x86 system like the departmental STU server, we'll actually see that this prints not less than. So that should be quite confusing and startling to learn that. Here's another example. So this is a program that uses floating point numbers. So you may have learned about double and float as floating point data types in Java, same in C. So we have A, B, and C as three different variables. A is a very large number. B is the negation of that very large number. And then we have number C, which is sort of an approximation of pi. So what this program does is it adds together A, B, and C. And on the left, we do the A plus B first, and then we add C. And then on the right, we do B plus C first, and then we add A. And so if those are the same, we print equal. Otherwise, we print not equal. So again, take a second and think about what you would expect this program to produce as output. So hopefully, it seems reasonable to you that it should print equal, because we're taking the same three numbers and we're adding them together. We're just changing the order in which we do it. But again, just like with the previous example, if you were to actually run this, you would see that it prints out not equal. So again, this is something that should concern you quite a bit at this point. One final example here is this is what's called a matrix copy operation. It's basically just a nested for loop. And the only difference between these two different versions, the A version and the B version, is that in the A version, the outer loop is running the variable I, and the inner loop is running the variable J. And then down here in version B, those are reversed, and the outer loop is doing J and the inner loop is doing I. But the actual data that's being copied is exactly the same in both cases. It's just a matter of the ordering of the loops. And so think about this for a second, and hopefully it seems reasonable to you that these should run at approximately the same speed. They're doing approximately the same amount of work, and so there's no reason for us to really believe that one of these should perform faster than the other one. But in fact, if we were to run this on a real system, we would find that one of these does, in fact, run faster. I believe that generally the version A is going to run faster. And so, again, this is something that might kind of shock you at first. And so what's going on here? So the core problem here is that something about our mental model of these programs, the way that we expect the programs to run, does not match with the system on which we're actually running them. And that's sort of the core discrepancy here. And so in the next video, we'll talk a little bit more about what a system is and what's going on here.